Hello, am I audible?
Yes, sir, you are audible. Sir, we'll be starting in a few minutes.
Shall I allow other participant to join?
Yes, sir.
Okay.
Good afternoon, everyone. Today marks a special occasion as we gather here to dive deep into the challenges and opportunities in the geospatial industry, a topic of immense relevance and potential. On behalf of the Symbiosis Institute of Geoinformatics, I, Tania, am thrilled to extend a warm welcome to Dr. Abhay Tiwari, our distinguished guest for today's webinar. It's a privilege to have you, sir. I also wish to welcome all the participants who have joined us for this event. Dr. Abhay Tiwari is a visionary in the field of data science and the founder of Spatiality AI, a leading geospatial intelligence company. His journey from a senior data scientist to becoming a CEO and guest faculty at BITS Pilani is nothing short of inspirational. Dr. Tiwari's extensive experience, including his tenure as a lead data scientist and data science manager, alongside his academic achievements with a PhD from the Indian Institute of Science, positions him as an authority in this domain. His dissertation on the evaluation of the collective eigenstates of emission of an interactive emitter matter ensemble, surface-based nanostructures, and numerous publications further attest to his profound expertise. As we look forward to an engaging session, I am confident that Dr. Tiwari's insights will not only enlighten us, but also inspire the students of SIG to explore new horizons in the geospatial industry. This webinar promises to be a thought-provoking exploration of the field's future, underscored by Dr. Tiwari's rich experience and passion. Now, I would like to invite Dr. Abhay Tiwari, sir, to share his knowledge and perspectives with us. Let us all make the most of this opportunity to learn from one of the best in this industry. Thank you, and once again, welcome to everyone attending today's webinar.
Yeah, thanks, Tanya. Thanks for such kind words, and thank you all for giving me the opportunity to talk with some young minds uh, and good evening, everybody. Good afternoon, everybody. So we have, I mean, during my PhD, I have been working on many different areas, and one of the areas was hyperspectral imaging. So that hyperspectral imaging was one of the area where it was so fascinating. But I was not working on the geospatial part, but hyperspectral imaging itself was a truly a game-changing area. And when I started looking to solve the problems in hyperspectral imaging, I found out that a lot of packages that were developed for satellite images and all. So that started my curiosity, and this is what it has eventually led me to um, form a geospatial company. I will briefly introduce in my talk briefly, like what exactly. So it is going to be more or less of interactive session. I'm just going to switch off my video in order to control the bandwidth. So, since this is not a classroom, I can't see all of your faces. I'm unable to make out whether sometime when it makes sense or it doesn't make sense. So, in case if you feel any bored or if you don't get anything, just you can ping me anytime. This is a very collaborative session, and I will be discussing very briefly. So, it's not like that. What I am discussing as a geospatial industry, the geospatial industry itself is pretty huge, and this is not even just the tip of the iceberg. And what I'm giving here is just part of my example, just part of my journey. So initially, I will just explain, what we are doing as a company. So, I mean, you all of you know, right? So, geospatial, the space science, rocket science, the complexity even start while, uh, you know, while collecting the data itself. So, like if you see this satellite here, I mean, the Earth is round shaped, or you can say as a potato shape. Now, the satellite gives you a flat image, right? So, what you do as ortho rectification, I mean, or ortho mosaic. So, from there, the complexity really starts. That how do you get a satellite image? How do you create a sensor which can give you a flat image? Right. So this is a very it's a very complicated science, and and from there you have to understand the relationships of the different electromagnetic spectrum with the material present on the earth, and from the relationship you have to find out some kind of intelligence or find some kind of some kind of uh, information which can be relevant to our day-to-day life, right? So this is a brief outline of my talk, and it's just like brief outline of our company, then what are the challenges, what we do, then what is the role of AI in the field. So our company is we are not a very GIS heavy for now. We are using GIS, some kind of GIS technology, but we are quite a lot heavy in artificial intelligence. And the role of AI is going to be huge in next decade in the field of geospatial. It's going to be used in every industry, but in geospatial, it's going to revolutionize the way the geospatial data people use, process, analyze, all those kind of each and every part. AI is going to help that, and then finally summary. So as a company, what the problem that we are solving? Okay, I mean, just a couple of slides. What it just gives you a glimpse that what geospatial industry and what this new age startup that people are trying to do. So we are problem. So we are a company who is working mostly for infrastructure sectors. The infrastructure sector, in case if you see somewhere around, the if there is any bridge construction going on, it's going on for years. Some metro line is going on for years, and sometimes people doesn't understand that why there is a bottleneck. So there is when some tender is allotted to some big company, what basically happened that that big company give subcontract to smaller companies, and they will be done for like for site preparation, some other company will be involved. For excavation, some other company will be involved. For concrete work, some other company can be involved. For design, every other. So there are various multiple layers, and sometimes what happen that these companies, they can become bottleneck to each as these processes. A lot of processes goes on in parallel. Sometimes they become bottleneck to each other. If site preparation hasn't been done, then excavation part is not done. If there is no electric cables, then something else is not done. So that is why the project keep on getting delayed and delayed. And uh, these construction is monitored through paper trails. So most of the report that will go to the top management will go through the paper trail, and top management will have very less idea that what exactly is going wrong in the field. So we are as a company, we are one of the company who give the information directly from the ground to the majority of the stakeholders. So this is what we call as the information is. And if you see like even the recent CEG report, so if you see like the CAG report that has come, that because of faulty DPRs, the detailed project report, so detail, sometime digital elevation model hasn't been done properly. Sometime the land cover hasn't been calculated properly. So even these kind of small things which you as a student, which you are doing on a regular basis, like land cover, digital elevation, digital surface model, all those kind of things. Even these small things, big companies, big governments are not able to do it right. So there is a very huge gap between the what people are learning in academics, what where the academics is, and where actually the industry is. And government, the CAG has also even given that what kind of robust monitoring and evaluation system there should be, evaluation system for monitoring of the projects. So, specialty AI, as I Tanya told, and this is geospatial intelligence company. What we do, what is geospatial intelligence? You guys already know, but just repeating it. So, first we acquire the image. We acquire the image from satellite partners. Sometime the satellite partners which are government owned, sometimes privately owned. Some from within India, some from outside India. Then we do the pre-processing part. That's the same thing. Then we calculate the structural element, spectral element of the images. Then we enhance the image so that we can measure the things very properly. And from there, we do the inference, that what is the information that is there. So we use GIS technology, like and AI and high performance computing. And once you understand, so it is not just the part, the structural and spectral element, we also look at the temporal part, that how changes has happened over time. So change detection is our major algorithm, that is what we worked on, that how what was something, what was there before, and what is something which is there after, and how much is the change. So first of all, is there a change? First finding a change, then to quantify the change, that what is the nature of the change. So that is that, if you understand, you can make a lot of other things. So I will give you, like, see, the algorithm, feature extraction algorithm, you can do a lot of algorithms. This is non-exhaustive list. Like in some images, suppose that if you just want to extract the building, you have certain algorithm. If you just want to extract the barren land, you have certain different algorithm. Now if you want to extract, let's say, road, there will be different combination of the algorithm, there can be different filters. Let's say if you want to understand about the health of a road, of the health of a building, or health of any infrastructure, you can use various different combination of algorithm. And again, like at time t, if something is there, and time t plus 1, if something else is there, you can find the chain detection. So I will give an example. So this is one of the example of what we have done. So this is what we use for infrastructure monitoring. So in March, you can see this is a rail over bridge which is coming on. So this is basically a railway line which is going on from the pedal, and there is a rail over bridge which is being constructed. Now in 2022, you can see the land has been cleared, but not majority of the work has been done. And in 2023, you can see some work which has been done, right? And then you use some kind of segmentation, you enhance the image, and this is what our chain detection algorithm. So it will tell you that at what part it just do that, what part something has changed and something has not changed. So this is basically image level, and you can see that this kind of, there is embankment and retaining wall which has come. So even we can go and physically we have seen that, okay, in 2023 there is retaining wall which was there. Now this is one of the example which we have given. This is one of the famous temple, Ram temple, which has come in Ayodhya. This I will give you about change detection algorithm, that what we have done. So what was there earlier and what was there now. So during finding out even the trees, what you can see. So our algorithm, it can find out that, okay, this tree was earlier also present, and this tree was, it is right now also present. So it basically tells you that, green part basically tells you where the things have completely changed, and blue part where things haven't changed. So what blue is, this part hasn't changed, this part has completely changed. So this is about finding that something has changed over this particular area. And this is one of the example. This is one of the Polavaram dam which we are doing for in Andhra Pradesh. There is a Polavaram dam, and you can see from this is a low resolution satellite image, so hardly you can see anything. This is the layout diagram which you can get from Ministry of Jal Shakti website. And once in this low resolution multispectral image, this is Sentinel 2 image, where you apply some AI algorithm, and you can see some really beautiful colors. Now these colors, they reveal a lot of information. So what's the information that you get. So I mean, first of all, this is one of the part where I have worked with some GIS specialist. And one of the surprising thing, with geospatial students is like, they sometimes miss the nuances of basic, some of the fundamental science, that of physics and chemistry, some high school science. So I mean, what basically happen is, every material is made up of molecules, and every molecule has certain bond energy, and that bond energy interact with the electromagnetic spectrum in a unique way. So the way that any material interact with the electromagnetic energy, that is basically the fingerprint of that material. So other material is not going to interact in the same way. Since this is a multispectral image, so of course the bands are broader. But if you go for hyperspectral image, you can even find each and every type of material. So as you can see, this purple color, they are, that is the constructed portion. Blue color is of course the Godavari river basin boundary layer. So now even we can find some, this kind of boundary layer, so where land and river meet, where land and water body, any water body meets, there is a water boundary which is being created. And these are the crust stone, and these are the some of the things which you can figure out that These are the construction material which is present, and from there we can actually verify that between Jan and June how much construction was done. So there is a new construction which was the construction on the spillway, that we can see that there is a new construction on the saddle dam area, there is a new construction on the powerhouse and the switchyard area. So this anybody can go and verify, from Ministry of Jal Shakti website. So this is broad level monitoring that anybody can do, uh, for construction. So of course, uh, this is a demo, but for the construction which is going on, we use very high resolution images, and at very high frequency. So that can even tell about even the fractional changes. Now, this is one of the thing, for Cochin International Airport. Like this is, we have been given a task to find what are the number of solar panels. So this is an example. This we haven't done for Cochin International Airport, but to find out, like, okay, I mean, what are the roughly installed capacity. So these are the satellite images. So solar sector is going very high in India. Solar sector, where government is putting a lot of money in the renewables. They want to understand that, what is going to be the total solar irradiation, total. Is there any shadow which is going to affect our solar panels. So let's say if there are large trees or large buildings or those kind of things, how they are going to affect, all those shadow analysis, and those kind of thing. Is there any water logging problem? So these kind of thing which we can get from the satellite imagery and entire GIS analysis. So there is various challenges in geospatial industry. I mean, I will just go through few of them. Technological challenges, business challenges, and there are some industry specific challenges. So, um, any question till now? Okay. So, like, so I mean, the new companies which are coming. So most of the GIS, so space as a industry, it was very largely controlled by the government, across the world. I mean, till now. So I mean, first US has been opened up, then India also has opened up in recent years, and how. Uh, yeah. So there is some new company which is coming up, and uh, what we have figured out that satellite images and GIS in silo is not one of the best optimal solutions. So if you use GIS along with other technologies, then it is a very very powerful entity. So if you use GIS along with, let's say, the drone images, or even with the CCTV camera images, that is somewhere where it's going to add a lot of value. So the this is the, like, for how you do the data integration, right? So near real time data integration, and in many cases what basically happen is, like, for actionable intelligence, you have to process vast amount of data, and that has to be done with very minimal human intervention to draw insights. So it require, complete geospatial, big data. That is a technological part. So there is a data explosion. There is a large number of satellite. They are collecting the data every day. They are they are uh, uh, there is huge data repository, and a large part of area can be monitored. But let's say if you want to monitor, let's say, agriculture, very large number of agriculture farms. Now not every it can be done with a human analyst. There is a limited number of skill set, people with this kind of skill set which are available. You can't do it for all area, let's say, in India. So you have to automate some of the part. You have to, this kind of, you have to automate some of the part to draw insights. This is a very big opportunity, that how do you geospatial big data query is a field in itself. So it's still the spatial data management. Even we as a company, we struggle that what is the right spatial data management. How do you maintain the data from different sources? Some is high, sometimes you get, for same location, sometimes you get high resolution images, sometimes you get low resolution images. How do you do the data fusion? How there can be hyperspectral images, there can be synthetic aperture radar images. So this data fusion how you retrieve the data faster, how process the data faster. That's a very huge challenge. That's something which is a very evolving field, which is and and as a challenge, of course, I will say, but there is a very huge opportunity in this area as well. So wherever there is a challenge, there is a huge opportunity. So for any student who have some uh, mm, who have some what I can say, who have some kind of interest in software industry along with the GIS. That's one of the very nicest area. So data, I explained, and then there are business challenges. So this is one of the biggest challenges. I mean, if you see private space industry, there is not a single company, a private company which is profitable yet, any larger scale company. There, because to build a business, we need a lot of downstream startups, and downstream means the startup like us who can generate data from who can generate insights from the data. So there is a lot of satellite companies, even India, which is a very big IT superpower. There is a huge lack of uh, you know uh, the IT company or software part software companies in India. So there are not enough software companies who have developed this downstream application. So understanding that how you can use the geospatial, so that this is where the challenge is. You can't, if you try to use geospatial analysis only in silos, if you want to develop a business only based on satellite images, it is sometimes it's not give it will not give you the right value. So how do you integrate with other resources? How do you integrate with something like the IoT data, or something like how or CCTV camera images data, or drones data. So this is a very open area. There is a very huge skill gap also, and uh, right now where the industry is going, there are uh, students who we have to understand that uh, that those that cutting edge level, those who can work at those cutting edge level, there is not there is very huge skill set gap. So sometimes we even face problems finding the right skill set, that somebody who understand each and every part, who understand data science also, who understand remote sensing also, who can understand the different data sets also. So if you go on what ESRA or Google Earth, there are huge data set. So how to get insight from the combination of data set, that also require an experience and an expertise in itself. Then there is regulation, ethical consideration, accessibility, affordability. These are the business challenges. Space industry is still, it's very highly regulated. So now there are after this there are industry specific challenges. So industry specific challenges like the urban planning, urban development, agriculture, farming, environment and natural resource management, disaster management, and emergency response. So urban planning is like one of the area which is one of the very fastest growing area in it. So I mean, uh, there is most of the people, they are now going to uh, so I mean, if you see urban planning, it's India has the second largest urban system in the world, okay? And it contributes 70% of the GDP. 40% of the Indians are going to live in urban areas, and 65%. So urban area in India is so poorly designed. It's I will give you with one example that I'm just giving an example of Hyderabad and Chandigarh. So if you see Chandigarh, most of the streets are if you see the street topology, road topology, they are very linear in nature. What you can see here as they are very linear. But if you see Hyderabad, they are much more haphazard, much more random. Sometimes the streets, what you can see here as, random in this way, random in this way. And then you calculate the radial histogram for the Hyderabad and for Chandigarh. You can see that for Hyderabad it's much more spread. Even for Mumbai and Delhi, if you will go, it will be even more spread. And for Chandigarh, you can see the spread is less. So Chandigarh is one of the area which is very plant city in India, and you can see that the traffic was in Chandigarh is very very less. So urban planning is one of the area where where there is going to be huge opportunities, like how uh, how to solve like waste management. And I will give you one more example. So and agriculture. So agriculture, I mean, there is a lot of companies who are working on agriculture, crop and production, and soil health monitoring. This is one of the area which is doing quite well in India. I mean, this is one of the where people are using. There is a lot of innovative agriculture companies where it's using, but compared to the scale what has been done till now, and compared to the scale where it should have reached, there is still huge number of gaps. Environmental natural resource management, uh, like environment, how uh, this water management, you know uh, you can say as like forestation, deforestation, all those kind of tracking, that is something which government is using uh, satellite images in some way or another. But see, I mean, using images is always one thing, but gaining the insights, like if you see for disaster management and emergency response. So if you see like how do you gain the insight? So when some earthquake happen in disaster management, uh, you as a satellite image you can analyze that there is pre-earthquake what was the situation, post earthquake what was the situation. But there is no company still who can tell that when some kind of disaster happened, this disaster agencies like NDRF and SDRF, they face a lot of problem in getting their utilities, in their getting their machinery to the right area, to the right people. So there are people, let's say if there's some earthquake has happened, and there are people who are somehow who are buried inside some debris. Now NDRF doesn't have, they don't know, because when some earthquake has happened, they don't know what is the scenario post earthquake. So where the roads are blocked, where the roads are not blocked, how they can get their machinery to the right place. That is how what is the extent of the damage, is that what are the layers of the building which was there, what is the what is the density of population that can be possibly under debris. So this huge amount of data, there is that assessment, these are during the first few crucial hours. Now there is not enough work which has been done in those kind of things, like there is urban flood is a very real example. Urban flood is, now you can see that there is urban flood in major cities, like if you see in Delhi there was a flood, in Chennai there was cyclone, in Bangalore there was urban flood, in Mumbai also there was urban flood. Now urban flood is like, what is the extent of the damage, what is the before and after, which area is more flooded, if that area is more flooded, how we can reach that area faster, is there any other area which is which is still accessible. So this, there is for disaster response, there is a huge gap. Of course the information is there. So information is always one thing, we can get the information, but in from the information, how we can get the actionable intelligence, there lies the opportunity. So as a student, whenever you guys are looking at the new opportunity, you should always look around, you should always see that how you are going to solve this problem. So let's say if you see the garbage problem, so of course you from a space or from hyperspectral imaging you can detect the garbage, right? So but if you, can you think about how you can design a solution to the municipality, how you can tell them that how you can locate the garbage, how you can this garbage is there. So that is there. For infrastructure development, again there is a huge opportunity that is which is going to be there. There is challenges. So like India is going under a very huge infrastructure transformation, where there is going to be multimodal connectivity, there is going to be rail connectivity, there is going to be waterways. So what waterways, when there was one of the interesting problem that we as a company we are doing with with IIT Delhi, and that how the sediment volume, sediment on the rivers, how the sediment volume and the sediment sizes do affect, and if there is some dam, how this, so even this dam they affect a lot of flow of the river. So how that river is flow is affected in each and every season. So we can get the data and we can tell that, okay, I mean in this season probably it's much easier to go through water, and in this season it's much easier to go through directly through train. So this kind of intelligence, actionable intelligence, is still a work which is in progress, which a lot of startup they need to do this. Better planning, better monitoring, there is a claim rebuttal, so it can help in insurance company. So there was one of the insurance battle which was going on. So there was one disaster which happened in Ladakh, and there was one of the dam which was washed up. So what were the causes of the dam, what was the causes of the disaster there is, and on those causes the insurance claims are based. What is the extent of the damage which has gone, right? How much of the machinery has been washed away, right? So these are the things, how you can measure, how you can. So like, just think of insurance as a sector. What happened in car insurance, like when you go in car insurance, there is a thorough inspection. They will tell you that, okay, headlight is gone, bumper is gone, and what things has been gone. Then they will evaluate and they will give that that kind of detail. So in this kind of scenario, there is not enough of the work which has been done, that what kind of structure, how you should detail each and every damage. Okay, so that is a huge amount of opportunity which is there. And this is one of the thing which I have explained. So traffic, I mean, even if you have to design a road, so I mean you can look about land use, land cover, and you can look at that, at those particular area, what is the road topology of the streets, and what is the road topology. So if that uh, particular point or the junction, is it going to be a congestion zone in the future. So this analysis, whenever a road is there, how will it become a congestion zone, or will it become a urban socio, how it's going to change the urban socio-economic uh, changes. So this Bangalore, you can see in 2003 2020, this is what you can see in increase in built up area. This is one of the analysis which people have done for lake and all those. So you can see the lake which is shrinking, and these are, Bangalore has 700 lakes, and right now Bangalore has just 200 lakes. So Bangalore is one of the area which is facing a huge amount of water scarcity, even after getting so much of rain. Because one of the primary reason is that lake has been encroached. So this urban planning, how this built up area. So you can see that there is a very huge amount of stress in the water resources. uh, Whereas in the net vegetation trend, so if you see within 0 to 20 kilometer vegetation trend, there is a still positive change, but built up area there is very huge change. So this factor of 1000 and 1500, and for water there is a huge amount of stress, and even there is a recharge potential of the water is going down very badly in Bangalore. So even if there is a rain, what the ground underground water is not able to recharge, right? So this kind of urban planning that is there. And there are some smart city where some kind of project has been started. There is some kind of measurement which has been done, but that is this is one of the example of Varanasi smart city. You can go on website, you can look at the smart city. They have found out, you can select some area, you can find that all the public toilets, dustbin, education centers, hospitals, these are properly geotags. So there are each and every part is geotag. You can know about that, which is the nearest center, which has the nearest banks, nearest police station, or nearest those kind of temples or religious places. And this Varanasi smart city has implemented for municipal service delivery. So that is one of the very interesting study which is there. Again, like you can see, there is a tender. So there was recently a tender from Sitco, from Mumbai, Navi Mumbai, that they were looking for geospatial based encroachment detection. So some people, like when you go for a traffic when some traffic violation happen. So nowadays traffic police doesn't interact with you. They just send you a challan on your SMS that yeah, you have violated traffic, and this is the fine, and either you pay or you fight in the court. So this is what similar government is planning, municipalities are planning for the encroachment detection. So anybody who has encroached, even Bhubaneswar has done a Louis project, and they have collected a lot of house taxes. Those who have done unauthorized buildings, those who have built unauthorized building within their compounds, or unauthorized swimming pools or those kind of things. So they have been able to collect a lot of house taxes. And where sooner or later you will see that this kind of solutions will be required in each and every kind of municipality. So this is one of the example of Varanasi municipality, but similarly you can see some from municipalities which are very of smaller cities, which are even you can get from them. And in the last part, I mean, I will just explain, what is the role of AI. So this is one of the area which we work on, and AI is a field, is a huge field in itself. So I mean, how do you use the AI algorithm? So AI algorithm, this is one of the object detection model. So how do you detect? These are for plane detection. These are again for that kind of, what you can say, tennis area, for some kind of let's say any kind of monitoring activity. So how do you use an AI that is AI requires a lot of image annotation, a lot of image analysis, and it also need ground level verification, ground level truths, which is there. And that's how you create. So AI can also help you in integrating the data with the other modalities. Again, generative AI, this is one of the example which we have done. This is super resolution algorithm, that the same, what you can see as same rail over which, this is a left hand side is sentinel image, and right hand side is a super resolution, what we have done. In this part you can see the edges very clearly, and once you understand the edges, you get the half of the information. So generative AI is not just about creating high resolution images. Super resolution is, of course, one of the area which is where you find that you can uh, I mean, if you see the cost of satellite images, the high resolution images are very costly. So if you have a way to convert low resolution images to high resolution images, you can save a lot of cost. You can save a lot of cost. But you can even directly create insight. So I don't need to just create insight of super resolution algorithm. I can directly create, let's say, super resolution based DEM, or super resolution NDVI, or super resolution NDBI, or SAVI, or those kind of thing. You can directly, from low resolution images, you can directly create, which is very high impact factor, high impactful, those kind of generative AI. So even how generative AI can be helpful in case of disaster management. So one of the model that we are training in disaster is like, uh, there is a lot of pre-earthquake model and post-earthquake model. So pre-earthquake and post-earthquake. So let's say if there is some area where there is no earthquake, which is already there. I mean, uh, uh, no earthquake has happened till now. But what will happen if there will be earthquake? Right. So simulating the disaster, you already simulate that, if there will be earth. So Delhi is probably in zone 4 or zone 3 of the earthquake prone area, and it's a very huge it's very densely populated. So how do you create the mitigation strategy even before, let's say, some catastrophe has happened? So how you are going to create a mitigation strategy for some places in Uttaranchal or some places in Arunachal or those kind of places where they are prone to earthquake, all those kind of things. So you can use generative AI to simulate disaster, which hasn't happened yet, but there is very high chance that it can happen. So this generative AI holds a lot of potential, in simulating or in understanding those kind of technology and doing that. So then there is opportunity in climate risk. I mean, climate risk. You can think about that: afforestation, reforestation, revegetation, all those kind of things. Like how uh, I mean, as a uh, like what CAs are doing right now. So there is a chartered accountant, like they take your all the profit and loss statement, they calculate your expenses, and they calculate the tax, and then you submit it to the government. So in businesses also, like especially the Western countries, they are trying to impose something called carbon tax. Like that, let's say if one kind of service, so what service that you are using, or what product that you are making. So let's say if I am making a steel from India, I'm generating a steel. So for 1 kg of a steel, how much carbon I have used? So it will be, it will be calculated based on that how much carbon it has been used. So how much, how much CO2 was used per kg, to get iron ore from mines to the factory, then again to transport it back from the factory to the um, some kind of port, and from port to, let's say, some European company. So that is my climate that can be used. Now if I will tell that, okay, I mean, I have done some CO2 emission, but again at the same time I have done some kind of reforestation, I have done some kind of, I have done some kind of reforestation. So you can mitigate that carbon risk. So Indian companies are facing huge number of challenges, Indian and Chinese both. I mean, they both are pushing. They are that, the Western countries, they want to push because they are going to be affected by climate science very badly. That's what the prediction is. So they want to push the developing countries in a way that, either you reduce the carbon. But if as a developing country, if you reduce the carbon tax, what is going to happen is like you are going to lose a uh, you are going to lose a lot of uh, profit. I mean, how you will create. So I mean, you have to use coal, you have to use iron, you have to use all those kind of things. You can't do it without, you can't produce steel without those things. So how as a developing country we can mitigate? So just like, there is CAs which are going for taxes, there are going to be a lot of people who will calculate the carbon footprint calculation, carbon credits, how much each and every company. So there is whatever the things that we are exporting, what is the carbon credit and all those kind of things. So this is one of the opportunity that, it can help you in making the positive change also. So you can, there you can design mitigation strategy for the companies, that okay, I mean, you can invest in renewable, you can invest in this, and then you can say that, okay, I mean, of course, you are slightly carbon positive in that, carbon negative in that sense. Water scarcity is also one of the area that I've just explained with the example of Bangalore. And so this is a summary basically. Like, the geospatial industry, it can revolutionize. And I mean, I can talk more and more. I will just let it for, any kind of discussion. I just saw some really fascinating questions which is there. So there is this, everybody, you guys are anyway doing masters and all those kind of, you will be knowing. So what I'm saying is, when you use an AI, so I mean one of the thing that, what I will give as an example of AI, uh, that AI is uh, that is not something like a plug and play. So AI is very much dependent on the end use case. Let's say I want to calculate the wind speed, and I want to calculate the wind speed, and let's say if I want to calculate the wind speed for a high rise building. Now for a high rise building, high rise building also calculate, like if you go in Mumbai, you see high rise building, and you people want to calculate wind speed, so that any high rise building swing. So they want to understand that how much swing it can happen. Is the building going to be stable or not going to be stable? So they are not worried about what the average wind speed you get or the low wind speed you get. They are much more worried about the extreme wind speed. But if you want to calculate the wind speed for a windmill, now windmill, what happened that beyond a point, the wind velocity doesn't matter, the wind speed doesn't matter. So whatever the more, even there will be more wind speed, you are going to generate the same power. So they are much more worried about the median wind speed calculation. So same problem, same data set, even the same target variable, but because of the end use which is different, your entire AI strategy changes. So whenever you look at it as an AI strategy, you have to understand that what is going to be the end use case. That is very, very extremely important. A purpose of any model, let's say if you give any model, I mean, let's say even if you do a physics model or an AI model, or any geospatial model, or so purpose of any model is to make the knowledge scalable and transferable, right? So that is how you create a model which is, how do you create the knowledge which is scalable and transferable. You have to understand end use case very, very very precisely. That is one of the area you have to understand, that what is the right level of any AI algorithm comes with the trade-off. So what is the right level of trade-off that you can manage, and you can still get away with that. So that is what I will say as an for an AI part. And I think that's it. That's it from my side. Any question if you want? There was a couple of questions. Shall I pick it up, or any other also question if you want?
Um, yes, sir, you can.
Okay. So shall I display the question? Just a second. Is it okay? I mean, any questions from this thing from my audience?
Thank you, sir, for the insightful presentation. Now we will begin with the question answer session. So the first question is from Shantanu Devvarma. How can graduate students like us contribute to the development and refinement of AI tools in GIS, either through academic research or industry internships?
Right. Thanks, Shantanu. That is one of the questions which we have, which I have just answered. And I mean, as a graduate student, you can understand that AI is one of the area which is developing, developing really fast. I mean, even as a AI researcher, we just sometimes feel overwhelmed that how this is changing. But if you want to, I mean, look at how you can use AI tools. Always look at the end use case, that why, where it is going to be used. Is it going to be helpful in that particular use case? Is it the right trade-off? What is the end use case which is there? And that is the only way that I can say. And academic research is I mean, you can do academic research or industry internship. Both are okay. Academic, even the industry right now, you can like a company like ours, where we have also academic orientation. So it's not something like where we don't do academics, because this is a research based industry. It's some of the thing where you have to understand very deeply at very deep layer. So that is yeah, that's the thing. So you have to, yeah, I mean, you can read more about it. You can read, what is the thing, what are the tools which are there. And I will say that when you are using AI, so AI is basically like, whenever it's basically a mathematical program. So you calculate something called y is equal to f of x. So f of x, f can be some really complicated matrix. It can be LSTM, it can be CNN, it can be SVM, it can be linear logistic regression matrix. So whenever you say y is equal to function of x, function of x can be very complicated matter, but there is a relationship between y and x. Okay, so there are x is basically many different input signals, and how do you get y? So there is some inherent relationship. So rather than you have to be very careful in understanding that as a that you shouldn't like while doing AI in GIS. Sometimes AI as a tool itself, it's so fascinating that people just keep on getting insight. They keep on reading about it, and they forget that what is the end use case. So that is see, I mean, AI as a field itself is growing. It's where a lot of big tech companies and a lot of big universities, they are already doing a lot of work. So you know you have to understand that either you want to be an AI developer or an AI researcher. So I mean, if you want to be a part of a developer where you want to develop the AI part, that is a different scenario. But if you just want to use AI as a tool, then you have to basically understand the relationship between y and x. That is one of the part where you have to focus more, not just the AI tool, not just to get infatuated by just the AI tools. I think
Thank you, sir.
yeah.
The next question is from Gayatri Gurumurthy from MTech Geoinformatics. The question is, with the advent of quantum computation, how much faster processing in the cloud platform is possible, and how will it influence the upcoming years of advancement in geospatial technology?
Okay, thanks, Gayatri. Quantum computation. Okay, that's quite a big thing. So, quantum computation is still, I feel that it's quite far from reality at large scale. It's not something which is still exists there. There is a lot of work which is yet to be done. Small scale quantum computation people have been able to achieve. So quantum computation, when it will come, it will do basically the factorization, the matrix factorization. What you do, that is one of the part where anything which require parallelization, that is one of the area where that is the kind of computation that quantum computation can revolutionize. So and in geospatial industry, we use matrix, especially in AI we use matrix factorization. So if you want to go at sub-pixel level, so let's say if you are using hyperspectral images. So hyperspectral images are there you can get 100, 200, 300 band. Now even sentinel images, like even you get 12 bands. So if you want to go at sub-pixel level, that within 10 meter by 10 meter, what are the possible material which is present in that particular pixel. So that sub-pixel level, you do some kind of matrix factorization and all those kind of thing. That is one of the model which is there. Even AI model a lot uses, like a lot of deep learning model uses matrix factorization and parallel processing. So of course, if the quantum computation will become a reality, it will change everything. It will even change the different part of the cyber security as well of the satellites. So it is going to be game changing, quantum computation. But I mean, I feel that it's quite far from the real. It can happen any day. I mean, it's just like there is possibility that tomorrow there can be quantum computer. So, and there is a possibility that even after 10 years or even after 20 years, there is no quantum computer. So there is a lot of thing which has to go right to in order to realize quantum computing as a reality. But yes, quantum computation, if it will come, it can change a lot.
Thank you, sir. The next question is from Tuhin Pal from MTech Geoinformatics. The question is, how can geospatial companies leverage emerging technologies like AI, IoT to create innovative solutions?
Right. So this is that's wonderful question. Thanks to you. And this is one of the area where which requires a huge amount of uh, uh, what I can say, innovation. So I mean, I will give an example. I was in Chennai when cyclone happened, and there was a complete disruption of power. So whenever some disaster happened, there is no power. Power is gone. That is the first thing that is going to happen. Now network also will be, very feebly, it will be somewhere not. Now if somebody can think that, in during the cyclone, can you design that, people will upload at some portal, people will upload some kind of mobile images in some portal, and you can create a, a complete flood map of the entire Chennai area using those kind of images and the satellite images. So you do that image registration which is there, or those kind of really innovative technology which is there. So this is one of the area where where there is a very huge potential, even in the area of mining also. So how much area which has been mined in a day, or how much this kind of so AI and IoT, that is one of the area where it is going to be the most it will create a large number of opportunities more than anything for geospatial industry. So
Thank
yeah,
you.
I think, yeah.
There's one more question. It's from Ashmita Banerjee from MSc Geoinformatics. So the question is, how can quantum computation help in improving deep learning?
Okay, I think I have already answered. Quantum computation is basically any kind of factorization, any kind of matrix factorization. So deep learning uses a lot of matrix factorization. Whenever you do that kind of back propagation, or those kind of neural network, all those kind of things, you use a lot of parallelization and all those kind of things. So it is going to change. But yeah, the question remains that when quantum computing will happen. So nobody knows.
The next question is from Alamkrita Maheshwara from MSc Geoinformatics. What are the implications of AI in GIS for the future of jobs in this industry? And do you foresee AI replacing GIS analysts for enhancing their capabilities?
Okay, that is, see, I mean, no one knows that, what AI will replace. It's not going to replace for sure. I mean, I will tell you that, even so, it will make GIS analysts more efficient. They will be, they will not be required to do the job which is very repetitive in nature. So GIS analyst, that is, I think that it's something which is, which will be, which I mean, see, GIS analyst is one of the places, like, where right now what GIS analysts are working. They are getting the images. They are, they are asked to calculate something. They are asked to measure something. Then they are asked to tell some other thing. So that is, of course, that kind of nature is going to change. So there is GIS analyst who will be asked to reason, and who will be understand that, how do you uh, how, when this thing happened. So it's still the algorithms are not so efficient that, it can understand the temporal part, a spectral part, and the structural part all together and create a story. So if something is happening, and a human will always understand that if this is there, it also has a bias that what is going to be happen also. So it is not that they have already an intuition that, if there is some. So let's say, even for a construction, I already know that, for a road, if the excavation has happened, now the next thing is going to be the some kind of bitumen work, or some kind of that, the WMM work. So that is my natural part. So if I get a pixel which tells me something different story, I will be able to understand that, okay, it may be something else, but that is what it should be, right? So, a human analyst will be always important, that is going to be there. And but a human analyst has to understand different modalities. Their job will be more or less to interpret the data, more or less to understand and interpret the intelligence part. And rather than, doing those kind of manual work, that is what I can see. It will actually increase their capability, I will say.
Thank you, sir. And the last question is from Kaustav Pramanik from MTech Geoinformatics. So the question is, what are the skills and competencies required to work in the geospatial industries for urban planning?
Yeah, so skills and competencies. I mean, I will certainly say that for all of you, I mean, like there is GIS softwares which is there, but if you in urban planning, so I mean, I will tell you about a Sidco tender that has come. So Sidco in Mumbai for encroachment detection. Now they wanted to establish a web application based on completely open source. So they don't want to put an application based on ArcGIS or based on some proprietary software. So if you are good in Python, if you are good in some kind of open source technologies, that is always going to be beneficial, because the critical urban planning and all those kind of things, they are the technology what I have seen till now. They, most of them are prefer open source quite a lot. So they either they will use QGIS or Python based those kind of technology. So if you really want to do the skills skill set, and if you want to work on urban planning is something which can't be done without government. And government as an entity, they prefer open source. So I will certainly say that if you want to get into that kind of thing, you should go open source. Of course, ArcGIS and all those kind of thing also are used even in government setups as well. So it's not something like that. It's not completely black and white. So you can use, but yeah, the more and more open source you use, the more confident you can. So I think that's.
Thank you, sir. Now Adrija will take over.
Good evening to all of you. My name is Adrija Biswas. On behalf of Symbiosis Institute of Geoinformatics, it is an honor to have had the opportunity to deliver this vote of thanks to Dr. Abhay Tiwari, our esteemed guest speaker, for the webinar on the challenges and the opportunities in the geospatial industries. First and foremost, I like to express our sincere gratitude to our esteemed speaker, Dr. Abhay Tiwari, for their insightful presentation and for sharing their expertise with us. Your knowledge and passion have enriched our understanding of the challenges and the opportunities in the geospatial industry. I would like to express my sincere appreciation to our esteemed director, Dr. T.P. Singh, and Deputy Director, Dr. Vidya Patkar, for affording us this esteemed opportunity. Additionally, I would like to acknowledge this diligent efforts and unwavering dedication of our esteemed program in charge, Dr. Dharmavir Singh, our placement officer, Bhakti Ma'am, and our supervisor, Sonal Rawal, and the entire placement organizing team, along with the technical and the IT department. Their meticulous planning and attention of details ensured a seamless and successful experience for all the participants, demonstrating commendable commitment to providing the valuable opportunities to our students. I extend profound gratitude to all the attendees of the today's webinar for their active participation, insightful questions, and invaluable contribution, of all of which greatly enhanced the success of this event. Your keen engagement not only fostered a more interactive atmosphere, but also significantly enriched the learning experience for all involved. Once again, thank you to Dr. Abhay Tiwari, our esteemed guest speaker, for sharing his expertise. Your presence and involvement have made a significant impact on the success of this event. In closing, let us carry forward the insights gained today and continue our journey of learning and collaboration. We look forward to more future engagements with all of you. Thank you once again for your participation and support.
Thanks a lot. Thanks to Professor TP Singh, Professor Ranveer Singh, and I think one more. Yeah, five. So yeah, thank you all. Thanks for any. If you want to reach out to any other question, you can reach out to me personally on my email as well.